Okay, let's get started. Can you see my shared screen? Let's start there. You don't see my shared screen? Okay. I'm going to share it again. Let's see. Can you see it now? Okay, awesome. So last time or in previous class, we started working on the functions. We just look at the basic concept of function. What is function and how we can represent function using different methods. That's what we have studied in previous class. Now today, we are going to look into a fundamental concept related to function, that is the domain and range of function. How we can find the domain and range of function. Basically, we look at domain, and in one problem, we'll also look at the range. Okay, how we can find the domain and range of the function given in different form. That's what we are going to look at. So let's just start with the definition. When I say domain and range, I have the definition for them here. The domain of the function y equal to f of x, from the previous class, we know that we can represent function as y equal to f of x, is the set of all values for which the function is defined. Okay, those values of x for which the function is well defined, that is called the domain. Those values of x which satisfies the function, or those values of x which, when you plug in, make sense to the function, they are called the domain of the function. And similarly, when we say range, range of the function is the set of all values of f, all values that f takes, or these are the output values. Okay, the output values of the function, they are called the range. So the other way of saying is the domain are input and the range are output. Domain are input and range are output. For example, in the function that is represented here using the diagram, the function, let's say that the function from the first state to the second state is a function f. If this is a function, then the domain of this function will be, all input values. You can see the input values are 1, 2, 3, and 4. So the domain will be 1, 2, 3, 4. That's your domain. And the range are these values. The output values are the range. So the range will be all the output values. The output values here are 1, 3, 5, and 7. So those are the output or range. 1, 3, 5, 7. Those are the range or output. So please copy all these definition and also this example, then we'll move forward. So I'm going to give you about a minute here to finish up that writing. Okay, I hope you are done copying it there. Let me know if you are ready. Okay, look like you are done copying it. So let's move forward. Let's go here. So now we are going to look at examples on how we can find the domain and range of the function. So here is our first example. Find the domain and range of the following functions. So here, the functions are given in the form of ordered pair, and we are asked to find the domain and range. So first copy the question again, and we are going to solve it. Okay, let's work on this. So first thing you need to know here is the function here is given in the form of table. So these are, I mean, given in the form of ordered pairs. So these are the two functions in ordered pair form. These are the functions in ordered pair form. So we have the functions in ordered pair form. And what we are asked to do is we are asked to find the domain and range of the function. So when function is given in ordered pair form, like in the previous example, you can represent using a diagram like this. Okay, you can represent using a diagram. So let's begin with the first part, A. So if we want to create a diagram for that, you can draw the two circles, or I should say you can draw two oval there. To represent a function. Can you see the shared screen, or is it frozen? What is it? Can you see my shared screen? Let me know whether you can see my shared screen or not. Or if it is frozen, just let me know. Okay, I see a message that I need to check here quickly. Maybe I was frozen a little bit. It's lagging. Okay. Is it back to normal now? Okay, good, good, very good. So see, what I'm trying to do here is for first part, I'm trying to create the diagram to represent the function. So for each of the functions, we can do that. So I'm doing this for the first function. You can also draw the diagram along with me. So this function is function f. This is our function f, like that. Now, let's draw the diagram fully to represent the function. So here you can see that 2 is mapped with 10. That is the meaning of 2 comma 10. 2 mapped with 10. 3 is mapped with 10 again. So 3, 10. 3 is mapped to 10. 4 is mapped with 20. So 4, 20. 4 mapped to 20. 5 is mapped with 30. So we write 530, 530, and then 6 is mapped with 40. 6 is mapped with 40. So once you draw the diagram like this, it is easy for us to write the domain and range because all these input values, they are domain. Okay, all the input values, they are domain. So the domain of this function will be, it will be 2, 3, 4, 5, and 6. So these numbers, which are also the input values, they are called the domain. Now we need to write the range. Let's write range here. Diksha, could you please unmute yourself and tell me what are range? Diksha, you can unmute yourself.
The range is 10, 20, 30, and 40.
Very good. So the range will be 10, 20, 30, and 40. 10, 20, 30, and 40. That will be the range. So it's always easy to create a diagram, and then from the diagram, whatever is the input value, that will be the domain, and whatever we have the output value, that will be the range. Okay, let's repeat the process for the second part, B. So for B, first we are going to draw the diagram to represent the function. Please draw the diagram along with me here. Okay, so the second function we have here is function G. You can see G is the function from first set to the other. We write G there. And then we label those mapping. -5 map to 4, or -5 mapped with 4. Then 0 mapped with 0. 5 mapped with -4. 10 mapped with -8. And 15 mapped with -12. So you can see this is a one-to-one function because one element with mapped with one element on the second set, right? Now, if we want to write the domain and range, let's find out what will be the domain. Domain is the set of all input values. Okay, set of all input values, they are domain. So Prakriti, if you can unmute yourself and tell me what are domain, that would be wonderful.
I think it's -5, 0, 5, 10, 15.
That is right. That's right. Thank you. -5, 0, 5, 10, and 15. That is the domain. Very good. Now let's think of writing the range. Let's see to whom I can ask this time. Pooja, could you please unmute yourself and tell me what our range here?
The range is 4, 0, -4, -8, and -12.
Awesome. Thank you. That is correct. So the range is 4, 0, -4, -8, and -12. So what we did here in our first example is the function was given in the form of ordered pair, right? And we represent the function using the diagram here. These diagrams that we have drawn here, they are called the balloon diagram, okay? So we represent the function given in ordered pair in the form of balloon diagram. And looking at that, we have written the domain and range, or we are able to identify the domain and range. So before we move on to another example, if you have a question, you can ask me. Otherwise, just finish up your writing. Then we'll move on to the next example. Okay, look like you are done copying that. Let's move on to next example. Now here you can see that we are asked to find the domain and range of the following functions. There are 4 functions here, and all functions are given in the form of equation. Okay, so you'll see a lot of problem like this in your quiz and in your exam when you're working on the domain and range of function. You'll see few questions where they will give the function in the form of ordered pair. Okay, but you'll see more questions from equations, because we also use equation to represent the function, and this is the widely used method. That's why you'll see different type of questions based on the function given in the form of equation. It doesn't mean that you'll just see the question on equation. There might be the other form also, that will be the graph, but we'll talk about graph later on. We are going to spend a little bit of time on finding the domain and range of the function in the form of equations. So let's work on the first part. Let's begin with A. So in A, they have given a function f of x equal to square root of 2x plus 3. You can see this is the square root function, right? It's a square root function. So for each type of function, there may be some restrictions. So if there are restrictions to the function, you have to look for those restrictions. So if you think of a square root function, you can also play with your calculator right now, if you have calculator with you. The square root function is well defined if this quantity inside square root is 0 or positive. Okay, if it is 0, for example, if we want to find the square root of 0, we can find it. Okay, if we have a number greater than 0, like 1, 2, 3, 4, whatever it may be, square root of 1 or the square root of 2 or the square root of 3, you can find the square roots. But if you try to find the square root of a number less than 0, say for example negative number, you cannot. If you try to find the square root of -2 in your calculator will say syntax error or something like that. Okay, meaning of that is the real valued function that is given here is not defined for negative number. It's defined only for positive number. And if you look at the definition of the domain of the function, you can see domain is the set of all values of x for which the function is defined, right? For which the function is defined. So here, this function is defined only when the quantity inside the square root is greater than or equal to 0. So we can write that f of x is well defined if 2x plus 3 is greater than or equal to 0. That is the only possibility. Okay, this function is well defined only when 2x plus 3 is greater than or equal to 0. Otherwise, this is not defined. Does that make sense up to there? Okay. So we got an inequality here. We need to solve this inequality and find the value of x. So if we want to solve that inequality, what we can do is, first thing is, we can subtract 3 on both sides. So it will be 2x is greater than or equal to, if you subtract 3 or if you move this 3 to the other side, it will be -3. 2x is greater than or equal to -3. Okay. Now to find x by itself, you have to divide on both sides by 2. So what we get is x is greater than or equal to -3/2. See, last time we learned how to solve the inequality. We are using that over here. So we saw that this function is well defined if x is greater than or equal to -3/2. If you want to represent this using the diagram, or number line, I should say. Number line goes from -infinity to infinity. we have x greater than or equal to -3/2. Maybe somewhere here we have -3/2. Greater than or equal to. Equal to means the point is also included like that. So we can put a dot like that. Greater than means all values to the right. Okay. So the domain of the function is everything from here, from -3/2 all the way up to infinity. So we can say domain is from -3/2 up to infinity. And you know, at infinity, we always put a parenthesis. Okay, at infinity, we always put a parenthesis. And at -3/2, this is -3/2. And at -3/2, -3/2 is also included. You can see a dot here or equal to sign. If that value is included, we put a bracket. Okay, we put a bracket like that. So that means the domain of the function is from -3/2 up to infinity. You can also draw a supporting graph for this one. Let me quickly show you the graph. Just a second when I try to bring the graph here. Can you see the graph now? See, here is the equation y equal to square root of 2x plus 3. And the graph starts from here. Okay, from the point there. So if you look at that point, it is -1.5 or -3/2. And it takes all values on the right. So it's from -3/2 up to infinity. We have graph on this side, right? Graph on the right of -1.5. That's why the domain is from this value, this x value, which is -1.5 or -3/2, all the way up to infinity. So please include that graph on your note so that you can clearly see the work is validated by the graph. Okay. Can you see my split screen? Okay. So after you are done with this writing, you should sketch that graph so that you understand that the domain is from -3/2 up to infinity. So if you have any question on this first example, part A, where we find the domain of the square root function, you can ask me now. If not, we'll move on to the second one here. Okay, look like there is no question. So we are going to work on the second problem now. So let's work on B. So the first function that was here, see, f of x equal to square root of x plus 2x plus 3, that is a square root function. Okay, you also need to know the name of the function. That is the square root function, function involving square root function. Also this d, that's also the square root function. Now B, we have g of x equal to 5 over x minus 1. So you can see this function is in the form of a fraction. If you see function in the form of a fraction, it is called a rational function. It is called a rational function. Function in the form of a fraction, that is called rational fraction. Now we have to look for restriction, if there are any restrictions. See, this is a fraction, and what we know is in fraction, denominator cannot be 0. Is that right? In fraction, denominator cannot be 0. That means this quantity cannot be 0. So the function is well defined if the denominator is not 0. So that's where we start. So we say g of x is well defined. G of x is well defined if x minus 1 is not equal to 0. If the denominator is not 0, the function is well defined. So now you can see x minus 1 is not equal to 0. If we want to solve this, we have to move this -1 to the other side. So it will be +1. So what we get is x is not equal to +1. So meaning of that is this function is well defined for all values of x except 1. Because if you plug in 1, 1 minus 1 will be 0 in the denominator. So if we want to represent this using a number line, let's do it. If you want to represent this using the number line that goes from -infinity to infinity, it takes all x values from -infinity to +infinity except this one. So 1 is not included. So over there, you can put a circle. It does not take that 1, but it takes everything below 1, that is all the values on this side, all values less than 1, and also all values more than 1. It will take all values less than 1 and all values more than 1. The only value that it will not take is a +1. So the domain is everything but 1. Okay. And the way we write it is like this. So you can say domain is from, you can see the first interval, it is from -infinity up to 1, and then from 1 up to infinity. So -infinity up to 1 is not included. And then from 1 up to infinity, again, the 1 is not included. And we already know in our inequality chapter, if we want to write this as the combination, we put the u in the middle, the union sign u in the middle. So the domain is from -1 up to -infinity up to 1, and then from 1 up to infinity. We can definitely verify this one also using the graph. Okay, we can also verify this using graph. So first copy that, and then we are going to look at the graph. So there is the graph, you can see. That is the graph of the function. If I make it a little small, see, it is taking all values except this 1. At 1, if you go all the way up or all the way down, we don't have the graph. We have the graph for all values less than 1. And also we have the graph for all values more than 1. Okay, so at 1, we have a vertical break, or we can say that there is a vertical asymptote at x equal to 1. I don't know whether you have finished copying that or not. Let me keep that on screen for a little bit. I was muted there and but talking. Sorry about that. So we are just done with the second one here. That's a rational function. a function in the form of a fraction. So whenever you are looking for the domain of the function that's in the form of a fraction, make sure your denominator is not equal to 0. That is the key there. In the first one, in the square root function, the quantity inside the square root should be greater than or equal to 0. So those are the key things that you need to remember. If you have any question on B, you can ask me now. If not, we'll move on to C. Okay, look like there is no question on B. So let's move on to C. If we look at C, we have h of x is equal to absolute value of 3x plus 1. H of x is equal to absolute value of 3x plus 1. So you can see this function involves the absolute value. So that's why this function is called the absolute value function. Absolute value function. And what we know is in case of absolute value function is well defined for all values of x. You can plug in any value of x, okay? You can plug in any value of x and the output or the value of the function is always positive. Is that right? Whatever you plug in, whatever number you think of from your number line, you can think of negative number or a positive number or 0. If you try to find the absolute value, you'll get a positive value there, right? Positive value or 0. So that means whatever the value of x may be, this function is well defined. You can plug in anything you want. Even if you plug in, say, for example, -1, look at the function. If you plug in -1 there, 3 times -1, that will be -3. -3 plus 1, that will be a -2. And absolute value of -2 is a +2. So by plugging in negative value, you will get a positive value. By plugging in 0 here, if you plug in 0, 3 times 0 is 0, 0 plus 1 is 1, right? Absolute value of 1 is 1. So even if you plug in 0, you are getting positive. Similarly, if you plug in 1, you'll also get positive. So this function is always well defined, whatever the value of x may be. So let's write that. H of x, let me use a different color. H of x is well defined for all values of x. That means there is no restriction. We can define the function for all values of x from -infinity up to +infinity. Everything from -infinity up to +infinity, that will be your domain. Everything, okay? Everything from -infinity up to +infinity, that will be your domain. So you can write domain as the values from -infinity up to +infinity. There is no restriction on this function. So you'll see that the graph will, the graph of the absolute value function will be a V-shaped graph. So it will start at a point and it will go all the way up to +infinity and -infinity. That is the meaning of that. And you can also check the graph quickly here. So let me show you the graph. That is the graph. You can see the graph is extending like this. That means if you extend infinitely, it will go all the way to the -infinity and also to the +infinity. There is no restriction, no break in the graph. Okay. If we look at that, you can see it goes like that, right? It's going all the way to the +infinity and -infinity. So just sketch the graph to represent that. This is the graph of the absolute value function. And you can see the absolute value function has 3x plus 1. If there is +1, the graph is shifted to the left. Is that right? If there is +1, graph is shifted to the left. So if you look here, instead of starting here at 0, it is starting here at 1. Not exactly 1 because there is a factor of 3. So a little bit on the left. It is negative 0.333, that is negative 1/3 comma 0. That's where the graph starts. That is the vertex of this absolute value function. Okay, absolute value function also has this tip point called vertex, just like in quadratic function. Okay, finish up your writing before we move on to next one. Okay, so we did C, that was the absolute value function. Are there any questions on C? No question on C, right? So probably you have seen that A was awesome, B was beautiful, C very cute, right? Let's find how is D. So let's go to D. In D, we have the function f of x equal to square root of x squared plus 1. Like in the first part A, this is also a square root function. This is also a square root function. And you know that for a square root function to be well defined, the quantity inside the square root must be 0 or more. So we say f of x is well defined if x squared plus 1 is greater than or equal to 0. So we are looking at this inequality, x squared plus 1 is greater than or equal to 0. Let me solve right there instead of writing here. See, now we have x squared plus 1 greater than or equal to 0. If you want to solve this, what you'll see is in next step, you'll subtract 1 on both sides, or you'll move this positive 1 to the other side, it will be negative 1, right? So you'll get x squared is greater than or equal to negative 1. Try to understand the meaning of this one. See, x squared is greater than negative 1. Now, if you think of any number on the number line, when I say any number on the number line, from negative infinity up to infinity, okay? If you think of any number on the number line, let me also draw that here, a little bit below. You have 0 in the middle, like that. Now see, if you think of any number less than 0, look at the screen. If you think of any number less than 0, number less than 0 means negative number, right? If you think of any negative number, you can think on your head right now, maybe a 5, negative 5, right? If you square a negative 5, that will be positive 25. 25 is greater than negative 1. Is that right? Yes, right? That's true. Similarly, now let's think of 0. If you think of 0, 0 is squared. If you plug in here, 0 is squared. That is also 0. 0 is greater than negative 1. That's also true, right? So this statement here is true for all values less than 0. Also for 0, let's check for values greater than 0. If you think for values greater than 0, maybe again you can think of a number 5 now, this time positive 5. 5 squared is 25, which is greater than 1. Is that true? So that means this statement is true for all values of x from negative infinity up to positive infinity. So this is always true. So this statement here is always true. This is true for all values of x. Okay, this is true for all values of x. So that means there is no restriction. You can plug in anything into this function and the function is well defined. Okay, you can plug in anything to this function and this function is well defined. So meaning of that is, Chandana, what will be the domain? You can unmute yourself.
Negative infinity to positive infinity.
That is very true. Thank you. So it's going to take everything from negative infinity up to positive infinity. So you can write domain, in this case, domain is from negative infinity all the way up to positive infinity. Okay. So if there are no restrictions, see, if there are no restrictions like in C and D, the domain will be from negative infinity up to positive infinity. But if there are restrictions, then what we do is we draw the number line and remove the restricted value and everything else will be the domain. Okay. So let's quickly check the graph of that function. Just a second when I bring that graph up. Okay, that is the graph. So that is the graph of square root of x squared plus 1. And you can clearly see it is taking all these negative values because graph is going all the way to the negative side. And also it is taking all positive values. Graph is going all the way to the positive side. And also it is taking that 0 because when you plug in 0, the value of the function is 1. And it's a square root function, the graph of a square root function with a square in inside. We have x squared plus 1. It was pretty much like the quadratic function. That's why you can see it's like an elongated quadratic function. Okay. So please sketch the graph of that on your notebook. And if you have any question on D, you can, the last one you can ask me. Okay, look like there is no question. So we are going to move forward here. So what we have done here is in this example, we learn how to find the domain of the function when the function is given in the form of equation, right? And each of these questions, they were quite different. A and D, they were a square root function, right? The restriction in the square root function is the quantity inside the square root should be greater than or equal to 0. B was a rational function. In case of rational function, the denominator cannot be 0. That is the restriction. And in C, we have the absolute value function. And you know that the absolute value function is defined for all values of x. It can be negative, 0, or positive. So technically, there is no restriction on this function, h of x, or absolute value function. So we look at two types of questions so far. The first one, the function given in the form of ordered pair. If the function is given in the form of ordered pair, we learn how to find the domain and range. What we have done here is, in order to find the domain and range, we created the diagram. And with the help of the diagram, we wrote all input as the domain and all output values as the range. Okay. Second one, with the equation by looking at the restriction. Now, let's find the domain and range of the function when the function is given in the form of a graph. Okay, that will be the third one. So before we solve this one, please copy the question and also sketch this graph in your notebook. Okay, let's find out whether you are done copying it or not. Let me check with Aditi. Aditi, are we done copying it? Okay, got a thumbs up from Aditi, so probably we are done. Okay, let's try to solve this now. So in this one, they have given a diagram, right? A graph is given, and we are asked to find the domain and range of the function. We have to find both. We are asked to find the domain and also range of this function. Now, when we say domain, these are the x values, right? Domain are the x values. So if we look very carefully, what we see is this graph, you can see, this graph goes from -3 along the x-axis. If we look at the x values, the graph is between -3 and 1. Let me also draw a line to represent that so that you can see. So if you look at that graph, you can see that the graph is between those two values, right? Between those two values. The two values are, the x values I'm talking about, the two values are from here, that is from -3 up to this one is a 1, right? That is from x equal to -3 up to x equal to 1. It is from x equal to -3 up to x equal to 1. So if we write the domain, the x value, the domain is from -3 up to 1. So we can write from -3 up to 1. Now we have to check whether these values are included or not. If you look at the graph, see, here we have a dot, right? Initially there was a dot there. I don't know whether you can see it now or not, but there is a dot there like this. Meaning of that is this value is included. 1 is included. So that is a bracket. That is a bracket. But if you look at -3 here, see, look at -3, there is a hole. You can still see that hole there, right? There is a hole. Meaning of that is -3 is not included. If the value is not included, that is a parenthesis. Okay. So the domain is from -3 up to 1. Because domain are the x values. That's why I draw those vertical lines to represent the x value. And we saw that the graph is between those two values. Okay. Similarly, to find the range, when we say range, these are the output values and or y values. So let's find out where is our graph in terms of y, from where up to where. So again, I'm going to draw the line. You can see here, everybody look at this screen. The lower part of the graph is here, down here, right? So I can draw a line there. That is the lower part of the graph. This is at y equal to -1, 2, 3, 4, y equal to -4. So it's from y equal to -4. That is the lowermost value. And it goes, the graph goes all the way up to here. It's not above the x-axis. It's always below the x-axis, right? So if we draw a line there, let's see. If I draw a line, I hope you can see my line that I've just drawn here in green. That line is, see, y equal to -4, -3, -2, -1. That means y equal to 0, right? That is y equal to 0. X-axis is same as y equal to 0. So the graph is from -4 up to 0. Okay, y values are from -4 up to 0. So your range is from -4 up to 0. But you have to decide whether these values are included or not. So if you look at the lower part of the graph, you can see here, there is a dot, definitely that is included. Also over here, although there is no dot, but the graph passes through that. It's taking both x and y values. So that means it is also taking that -4 over here. That means -4 is included. So we have a bracket there. We have a bracket. Now, if we go up here, look at this one. When y equal to 0, over here, there is a hole, right? When you look here, there is a hole that tells us that y equal to 0 is not included. But if we come here, there is no hole. That means this point is actually included, right? Although 0 was not included here, but it is included here. That means 0 is somehow included. So that means we also need a bracket there. So the range is from -4 up to 0. So sometimes the graph will be tricky. See, when you look at this point here, look like 0 is not included because there is a hole on the graph. But if we come here, 0 is included. So if it is included somehow, you must have a bracket. Okay. And also this graph is not just helping you to find the domain and range. It is clearly telling you that the domain are the X values, the vertical lines that I have drawn here. It is from the lower X value up to upper X value. That is your domain. And then if you think of the range are the output values or Y values. So we look at the lower Y value, which is at -4 here. And then we go to upper Y value, which is 0. So from here up to here, we have the graph. That is the range. Range is this one. From here up to here. Okay, that is the range. How much you want to grow? Your range, right? And then domain, from where? That is from what age up to what age? Just like that. Okay, so that is the difference between domain and range. In the graph, the horizontal axis or X axis, the values on the horizontal axis or X axis, they are the domain values, and the values on the vertical axis or Y axis, those are the range values for the graph. Okay, so you really need to know how to analyze the graph and then find the domain and range. So we are going to work only up to here today. Before you leave, last time from your exercise, I asked you to solve first 3 problems only. Okay, some of you have done more than that, which is wonderful. Now today, what I want you to do is, I want you to do some additional problems. So you must complete everything up to problem number 8. Okay, so 1 through 3 you have already done. So 4, 5, 6, 7, and 8. That is your homework for this week. And also before you go, please go to the main page of your course cell and complete the attendance. That is all for now. Enjoy your break, weekend, and I'll see you next week.